So in the first couple of videos, we mentioned that a function must have at least one input value, a mathematical formula or a mathematical rule, and an output value. However, you're going to find that sometimes instead of using the word input value and output value, I sometimes refer to them as independent variables and dependent variables. So what is a variable? A variable is a symbol, and sometimes we use letters to represent that symbol. And the variable is a symbol that represents a value that varies or changes. Right? It's a quantity that changes based on the context of the problem that we're looking at. So an independent variable is a variable that doesn't change based on another variable, which means it's independent. It doesn't depend on another variable. So an independent or an input value, the input value of a function is sometimes called the independent variable, right? Because it doesn't change based on another variable. Right? What that means is that the output value of a function, right? So what we get out of our function machine depends on what we put into the function machine. Therefore, the output value is the dependent variable, right? So a dependent variable is a variable that changes based on what you put in for the input value. Therefore, the dependent variable is dependent on that independent variable. Okay? All right, so I just want you to make sure you're aware that when I say input value, I'm referring to the independent variable. If I talk about an output value, I'm referring to the dependent variable. Okay, and it's nice to remember which one is which, because when you start graphing these functions, so when I start graphing these functions, usually we graph on an xy plane, okay, and we usually think of our x-coordinate as the horizontal axis, and our y-coordinates, we graph them on the vertical axis, right? But you can think of x as your input value and y as your output value. Therefore, anytime you have a word problem and you have to graph your function, you always want to graph your independent variable. So you always want to graph your independent variable on the horizontal axis, and then you're going to graph your dependent variable on the vertical axis. Dependent variable. Okay? All right, and this really makes sense. If we go back to the last two examples that we looked at when we were working with functional notation, okay? Remember this example about the profit that you make after T years of opening your business, okay? All right, the input value is T, and T is time. So time is years since you opened the business, right? Does the year depend on the profit that you make, or does profit depend on the years? So in this situation, it makes sense that the profit is going to change depending on how many years since you've opened the business. So here it makes sense that the profit is your dependent variable and your T is your independent variable. So then if I actually had a formula for this problem, when I graph it, oh gosh, that's such a horrible line, but when I graph this, that means I would graph T on the horizontal axis and P of T on the vertical axis. Okay, same thing with this example down here, S27. Okay, all right, we're looking at the length of a fish and the top speed of a fish. So again, you want to ask yourself, does the length of a fish depend on its speed, or does the speed of a fish depend on how long it is? So in this situation, it makes sense that the speed of the fish depends on how long it is. So S of t, therefore, must be our dependent variable, making the length of the fish the independent variable. Okay? And again, if we were thinking about graphing this function, if we had a formula or some points, right, we would graph L on the horizontal axis, and we would graph S of L on our vertical axis. Okay? So just make sure you're aware of those vocabulary words. Now let's take a look at an example of a function that's given to us as words. So in the last couple of videos, we looked at functions given to us as a formula. We also looked at functions given to us as a graph. But how do we tackle functions that are given to us as a word problem? And I'm going to adjust my pen here so my handwriting is a little bit better, so excuse me. Let me just quickly fix this. Okay, now let's take a look at this example. So suppose your job pays $15 per hour and you work different number of hours each week. So maybe one week you work 10 hours, another week you work 40 hours, right? And you want to know how much money would you make based on the number of hours that you work each week. So the question that we want to ask is there a way for us to model, and what I mean when I say model is there a way for us to write a formula or an equation to represent this mathematical situation, okay? So when I say model, that's what I'm referring to. Let's come up with a formula to represent or model the problem at hand. Okay, so is there a way to model this mathematical problem so that you could determine how much you would make if you worked a certain number of hours? So anytime you're dealt with a word problem, or dealt a word problem, I want you to think about these 5 steps. And we're going to go through these 5 steps step by step. But once you start getting used to working with word problems, right, you can go through these 5 steps mentally instead of breaking it down like what we're doing here. So the very first thing that you want to do anytime you have a word problem is you want to make sure you identify and label the variables, okay? So go ahead and stop the video for a second and think about what the variables are in this problem. Okay, so in this problem, we're dealing with 2 variables. There are 2 things that change, all right? The first variable is the number of hours that you work, okay? So number of hours worked. Okay? Maybe one week, like I said, you work 10 hours, another week you work 40 hours. So that's one variable. Now we want to make sure that we label this variable. So let's give it a name. What do you want to call it? Maybe we want to call it H. Okay. And again, you can call it anything that you want. You can call it H, you can call it N, you can call it X, you can even call it happy face. Okay? Right? Just as long as you define it, you can call it anything that you want. Okay, so there's our first variable. What's our second variable? Our second variable is how much money we make. So how much money, or I'll say we earn, okay? And now you also want to give this variable a name, all right? And again, how much money we make changes or varies depending on how many hours we work. So let's call it something. What do you want to call it? How much money we earn. Let's call it S, okay? So now we have 2 variables. Now let's determine which one of these variables is the independent variable and which one is the dependent variable. So the independent variable does not depend on another variable. So we want to ask ourselves, does the number of hours we work depend on how much money we make? Or does how much money we make depend on the number of hours that we work? So hopefully you can see that how much money we earn depends on the number of hours we work and not the other way around. So that means that the independent variable then must be the number of hours worked, and the dependent variable is the number or how much money we would earn. Okay? All right. So I'm going to go ahead and rewrite this using functional notation. So I know that my independent variable is H and my dependent variable is S. Let's use function notation to show that S is a function of H, or S depends on H. So I'm going to just rewrite this, and I'm going to say S is the same thing as S of H. Okay, so I'm going to call this function S of H. And again, I'm using S, but you can use any variable that you want. You can say, I'm going to let S be F of H, or you can say, I'm going to let S be G of H. It's completely up to you. The F or the G, that's just a name that you're giving to the function. So you can name it anything that you want, as long as you define what that name is. So here, I'm calling the function S, and I'm naming it S, and I'm saying that S of H means S, right, when my input value is H. Okay, So again, our goal is to try to come up with a formula to model this scenario. So in order to help us write a formula, it's always a good idea in the next step to work out a few small examples just to see the relationship between the two variables. And in mathematics, as soon as you see a pattern that demonstrates a relationship between the variables, that pattern usually leads to a formula that models that scenario. Okay, so let's work out a few examples. So we're going to say, let's suppose, let me move this up. Okay, so let's suppose that we work 10 hours. Okay, then what is the money that we earn? So what is S going to be? Okay, let's work this out. So what would we do? We know that we make $15 an hour. So if I want to solve for S, so if I want to know what S is, we would take the $15 that we earn per hour, and we're saying suppose we work 10 hours. So then we would multiply that by 10, okay? And that tells us that S is equal to $150, okay? All right. Let's pick another input value. Let's suppose that H is, let's say we worked 40 hours that week. Then what would S be? Okay, and again, we can go through and work it out. So if I wanted to know what is S, to get S, we know that we make $15 per hour, and we worked 40 hours, okay? So that means that, I'm going to go to my calculator here. So what did we say? 15 times 40 hours. Okay, so that means we made $600. Okay. All right, and I can keep going, but I think this is enough to kind of see the pattern. So what we want to ask ourselves is we want to say, how do we get S, right? And how is S related to T? So notice that in our work, to get S, what we did was we took 15 and we multiplied it by T. Again, down here, to get S, we took 15 and we multiplied it by T. So the general equation is to get S, we take 15 and we multiply it by T. So there is our formula. So I'm going to write my formula down here. S is equal to 15 times T. Or if we want to rewrite this using functional notation, I can say that S of T is equal to 15 times T. So we get a really beautiful formula, and actually this, is the answer to step 5. Okay, so I take my function and I rewrite it using functional notation. And now that I have the notation, I can start answering questions like, what is, so then I can start answering questions like, well, what is S of 36? Okay, all right, or I might want to answer the question, what is S of T equals 700, right? And so this is saying, how many hours do I have to work to earn $700, right? And it's nice to be able to ask those questions using functional notation. Okay, I leave the next 2 exercises for you to do on your own.